So what I'd like to show you is one of my favorite cases. This is the latest version of suiteHEART 5.0, which has the new Virtual Fellow feature. You can see here the software has already, as part of pre-processing, analyzed the left and right ventricular contours, and the Virtual Fellow feature has automatically selected the short axis and long axis images, and it displays them in a standardized fashion with a 2-chamber view here, 3-chamber view, 4-chamber view, and then short axis images base to apex. And it will always display these images in this way, regardless of the order in which the images are acquired. Now, if we look at the ventricular function, it looks pretty normal. If we look at the numerical data, I can click here and we can see the LVEF is 58%, the RVEF is 54%, both ventricles are mildly dilated. Now I can switch over here to this icon, which shows delayed enhancement, and again it shows the 2-chamber view here. The 3- and 4-chamber view aren't shown because none was acquired, and we can see the short axis images here, and it looks reasonably normal. We can actually compare the function and viability images by placing them side by side with each other here, and so now you can see the function image at one level is displayed with the delayed enhanced image at the same level, and we can see how these images correspond with each other. I can page down here towards the apex, and again the viability and function images look pretty normal. I can also look at the resting first pass images. Here you can see some first pass images while contrast was given, and we can even display the first pass images next to the delayed enhanced images, so you can compare the first pass to the viability, and again these images look rather normal. Now, why is this one of my favorite cases? Well, one of the nice things about suiteHEART is it will automatically pull up the old case for you and allow you to do a comparison. So here I'm just going to click on this icon so we can compare the functional data. And what you'll notice here, for instance, in the 2-chamber view, is that the old image is displayed in this, the old study is displayed in this column here. The new study is displayed in this column here. And if you look at the inferior wall, you'll see it used to be thinner and not contracting as well. Again, you can see it also in the 3-chamber view. And if we look here at the short axis images, you can see in this row, number 1 would be the current study, number 2 would be the old study. If we compare this image from the current study to this image from the old study, you'll see that there used to be a wall motion abnormality, which is now gone. Here I've shut off the contours maybe to make it a little bit easier to see. You can see here the old image here, the new image here. You can see the old study, the wall was thin and dyskinetic. The new study, the wall is thicker and it functions well. And if we look at the data, the numerical data, what you can see is that the old study, the LV ejection fraction was 47%. The new study, the LV ejection fraction is 58%. So we've had an improvement in global systolic function. And actually, when you look at the volume versus time curves, you can see that in the old study, the volume versus time curve for the LV was above that of the RV. And now in the new study, the LV volume versus time curve is below that of the RV. And we can close this here. We can look at the viability images, which I'll compare here. And again, you can see the old study is number 2 in this row. You can see the inferior wall was thin, but there was not enhancement. In the new study, you can see that the corresponding slice is thicker. And so this is a patient who has been revascularized between the old study and the new study, and because there was no significant scar here, the LV recovered function. And if we compare the old perfusion images, which we can see here, and I can slow these down a little bit, and maybe limit it to the first pass here. What you can see here is that in the old study, again, number 2, you can see there's an area of even resting ischemia, which is not present in the new study after revascularization. So this is a nice example of how Virtual Fellow can automatically save you time by pre-processing the images and then displaying them in a standardized format where you can compare new and old studies without ever having to do the comparison manually. Thank you very much.